Fluent weights. All right, so Fluent weights are similar to explicit weights, but provide more flexibility in defining custom polling intervals and exceptions to ignore during the wait. You can use the Fluent weight class to create Fluent weights. Let's hop over to VS Code to see how this works. I went ahead and created a class called Fluent_weights.java, and the reason I'm adding this underscore is because we're going to be working with a class called Fluent weight, and I didn't want the compiler to get confused. Okay, so that's why I named it here with this underscore here. Okay, so I went ahead and copied some of the code from the previous video where we're instantiating the Chrome browser, maximizing the browser, deleting all cookies. I still have the implicit weight here, and we're not going to remove it. We'll keep it here. Moving forward, we're navigating to the website, and then here I'm inspecting, or I've stored this element here. Okay, this bootstrap dropdown into this type element here. This is the bootstrap dropdown here on this practice site here. This one right here, the same element we've worked with. Now, here's the thing. This, again, we're still working on the website that we'll provide to you so you can practice these scenarios, right? We don't have any weight issues so far, but I'm just showing you guys how to implement this and write this code out and explaining to you how it works, okay? Once the practice site is up and running, feel free to use it. And I'll also go ahead and record some other videos with this, okay? But here's where things get interesting. So line 33, we went ahead and created an object of the Fluent weight class, okay? And here we have to pass a WebDriver here between these anchor tags. We're giving this object reference variable weight equals new Fluent weight, and then we're passing the driver as an argument. But here's the thing, okay? Pay very close attention to this code here. There's no semicolon after this. There is no semicolon after this statement. There is no semicolon after this statement, but I have the semicolon after here, okay? And the thing is that this is all chained together, okay, to create one whole statement. I just went ahead and formatted like this so I can kind of explain to you the steps as to how this works, okay? But I'm going to show you how it really works, okay? How it would actually really look if I didn't format it this way, okay? So again, it's just one huge statement like this. So it would look like this. Okay, and I'll explain these methods in just a bit as well, okay? So it'll look like this, okay? So you notice it's a pretty long statement, and this is why Fluent weights are actually not commonly used, because the implementation of it is a little bit interesting, okay? So I'm gonna go ahead and do Control-Z. I just wanted to show you how this looks. So pretty much it looks like method chaining, kind of like how we used it first with actions class, where we're able to perform multiple actions in a single statement, okay? So I'm gonna do Control-Z, just bring everything back here, and we would be here, okay? So let's talk about what is going on in this statement here. So the first method we're using is called with timeout. And as an argument, we're passing the duration of the time. We're setting the maximum time out for this duration, okay? So again, instead of using an explicit weight, we are using a Fluent weight. So the amount of time we specify here would be higher than your implicit weight, okay? And then there's a method called polling every. And here we're specifying the duration of the time. We're setting the polling interval. I'll talk about this in just a moment. Then we have the ignoring method where we are ignoring the exception. Okay, so here's how this works, okay? So Selenium weights can sometimes be a little bit unreliable, okay? The Fluent weight gives you more flexibility and is actually more robust in some ways than the regular explicit weight. The reason for this is because if the page loads, let's say you're navigating to a website, you want to interact with an element, sometimes the page just loads too fast, Selenium gets a unreliable response, okay? And your test case just ends right there, and you're probably wondering like, wait a minute, I told Selenium to wait 30 seconds to wait for the clickability of this element or visibility of this element, but it didn't even wait 30 seconds. It just crashed after 2 seconds or 3 seconds. It didn't wait 30 seconds. So you're wondering like, wow, is this wait not working? What's going on? Right? So then if you keep trying your program out and you keep running into the same issue, at some point you'll probably be like, you know what, let me just add a hard sleep, and you'll notice that that'll solve your issue. But this Fluent wait works very interesting. So in that case, in that same scenario where let's say the page loads and the element is there, but for some reason you get a flaky result, meaning an unreliable result with Selenium, this Fluent wait, this pulling every method will check every 2 seconds to see if that element is there, if that condition is there, okay? And it'll wait up until the specified amount of time here. So it'll check every 2 seconds. And for example, here's where we have the ignoring method. If the test case will fail because of a no such element exception, you're telling this Fluent wait, ignore this exception and keep trying just to see if it's there. Keep checking every 2 seconds, but go up until 30 seconds. And this is why this wait is very robust. It's actually more robust than a regular explicit wait. It's just that the implementation of it is a little bit tricky, right? And if you think about this, if we actually have to write Fluent waits a lot throughout a whole script, it becomes inconvenient. But don't worry about this right now, because when we start with framework design, we'll be storing this in a common function or a common method, and we'll talk about that later so that we can reuse these methods easily, okay? But here, the exceptions you would typically ignore are like a no such element exception, a stale element reference exception, and so on, right? So then after that, we'll just call the reference variable here wait until, and we can use the expected conditions class as well and use any of the conditions of that class. For example, here I'm using element to be clickable, and I'm passing this bootstrap dropdown as an argument, and then finally I'm just clicking on that dropdown or that element, okay? So this is how a Fluent wait works. In most projects will stick to implicit waits and explicit waits, mainly because of the simplicity of implementing them within their frameworks. But you can also do this as well with a Fluent wait in those really odd cases where you need something more robust. So go ahead and write this code out. Go ahead and play around or practice with some of the elements on the practice side. I do want to say again that we're developing a practice site so you can practice these scenarios, these explicit wait and Fluent wait scenarios as well. Just keep waiting a few more days. We'll make an announcement. We'll share the link in the description below. I'll also record new videos as well to kind of cover those scenarios as well, okay? I'll see you guys in the next video.